Good afternoon, everyone. Welcome to our webinar today. I see that there are a few people that are still logging on, so we'll go ahead and get started here in about another minute or so. Welcome, everybody, to our webinar today. My name is Jill Browning, and I'll be the moderator for today's webinar on increasing plant profitability by relieving cooling tower pain. Before we get into our presentation, I just want to let you know that you should be hearing me now. There are two options for audio. You can use the computer or via your phone. Either option should work just fine. And then lastly, if you have any questions throughout the webinar, please feel free to do so at any time. You should be able to ask the questions over to the right side of your screen. There is a questions panel for that. So feel free to ask any questions that come to mind, and we will try to get to as many of those questions as time allows. Now, I'd like to introduce our speaker for today's presentation. William Blanford is the Global Industrial Sales Manager of Hydrotech products for Veolia Water Technologies. William has worked in the water industry for more than 10 years with expertise with design and operations of water treatment plants. William holds a bachelor degree in engineering from Monash University in Australia, as well as a Master's of Business Administration from the Danish Technical University. And now I'd like to turn it over to William.
Thanks, Jill. Good afternoon, everybody. So I'm going to be talking about a product that's come out of Sweden. And firstly, I'll tell you a little bit about Sweden. It's a land of extremes with winters that can go down to -50 degrees Celsius and up to 35 degrees Celsius, which is an enormous temperature range. So they've become extremely good at building robust products, and probably the best known robust product to come out of Sweden is the Volvo. Now, the Volvo is actually known as the type of car that somebody would buy when they expect to have a crash. So it's a particularly robust product. Our product, likewise, is also very robust, and it's specifically good for reducing your risk profile. There are over 10,000 installations worldwide, which means that we've got a very good control over the process. When it leaves the factory, it can be assembled in a plug-and-play fashion, which will reduce your execution risk. And it's a very robust mechanically designed unit, which will reduce your operating risk. Now, the purpose of me bringing this up is because this can help reduce your risk profile at your cooling tower. And some of the ways that you can do that are by improving your water footprint, or by reducing the human health risk, improving operations and maintenance costs, or reducing efficiency losses. So I'm going to describe a couple of ways to do that. One of them, of course, being the water footprint, and this is becoming more and more important. Now, the easiest way to save water is to increase cycles of concentration, especially if your site is running at low cycles to start with. Increasing cycles from 3 to 6 reduces cooling tower makeup water by 20% and cooling tower blowdown by 50%. Now, the two limiting factors for improving cycles of concentration are dissolved minerals and solids. In this presentation, I won't focus on the dissolved mineral part. only on the solids. So our product is good at managing this component. CapEx investments for operations and maintenance savings are not always at the top of the priority list at industrial sites, but for cooling towers, there is a good chance to reduce risk and save money with small investments. Obviously, the biggest risk is collapsed fill. Normally, it doesn't go from the outside, but it will almost certainly have a big impact on your production. A similar business that sells cooling towers was telling me recently that they have a customer whose sand filters went down for 1 year, and they had collapsed fill as a result. The cost impact was $200,000 in material costs and $50,000 in erection costs. In addition, you can also damage sensitive equipment. For example, clogging up heat exchangers, like in the image you see on the left. This doesn't always have an immediate cost impact, but it will definitely hurt when you need to replace expensive parts of the plant, or if your efficiency goes down. And there's also opportunities for better plant performance. Improving water quality will likely improve heat transfer and condensers, which will improve plant efficiency and reduce fuel consumption. So better water quality also opens up the opportunity for recycled water consumption, for reduced power consumption by installing high performance fill. And this is something that you should be looking at if you want to save energy costs. Now, the obvious health risk for cooling towers is legionella, which causes Legionnaire's disease. A good example was reported by the LA Times, which cited that 22 cases of Legionnaire's disease was attributed to cooling towers at Disneyland in the fall of 2017. Now, besides the bad press which comes with an incident like this, there are also some legal ramifications which can be very serious. Legionella bacteria grows in biofilm, which is a heat transfer inhibitor. So dispersants are normally used to keep process surfaces clean, and this process strips biofilm growth off the cooling tower structure. It's then fluidized as a suspended solid. So doses of disinfection chemicals are used to kill the bacteria, but dead zones in the cooling tower can mean that chemical dosing is ineffective. So the best practice management for cooling towers includes limiting the water to a turbidity of 15 NTU. And the best way to do this is by installing a sidestream filter. Now, not all sidestream filters are equal. And I'm going to describe later in a case about how we showed some differences related to this topic. So regarding the agenda for this presentation, we just covered point number 1, the pain points at your cooling tower. Next, I'm going to cover how a Hydrotech filter works. Then I will give a comparison with sand filters. I will talk about intake water applications, case studies and references, and then finish up with sidestream filtration applications and give some more case studies and references. So this is an image of a Hydrotech disc filter. This is an inside-out technology where the water flows into a drum. The water passes through a disc and out through a filter panel, which is mounted on the disc. The clean water will be sitting inside a tank before passing over an outfall weir, and that clean water is used in a backwash process. The filtration cloth is a woven polyester media, and the coarseness or the grade of cloth, which is the distance between the yarn, the hole size, is going to define the particle size reduction. So if you've got a 10 micron cloth, it will be certain to remove particles which are 10 micron or larger. Now, the effectiveness at removing particles is to do with size, but also to do with strength and shape characteristics. Here is an example of some TSS reduction, which was achieved at the site. The blue dots are the feed characteristics of the solids, and the orange dots are the filtrate characteristics. At this site, we used a 10 micron cloth, and you can see here that basically all of the solids greater than 10 micron have been removed. What you will also notice is that particles smaller than 10 micron have also been removed. Now I'll show a video which describes how the process works from including backwashing. So just give me 1 minute while I load up the video.
Hydrotech, a subsidiary of Veolia Water Solutions and Technologies, is the world's leading manufacturer of woven cloth filtration systems. The Hydrotech Discfilter provides continuous filtration of water with the advantages of low power consumption and footprint. The Discfilter is manufactured with several discs mounted onto a central drum. Periodically, the drum is rotated while a moving nozzle assembly backwashes the filter media in order to maintain continuous flow through the unit. Hydrotech's proprietary woven filter media is attached to individual media panels, which are installed on each side of the filter discs. Water flows into the unit by gravity and passes through openings in the drum to the inside of the filter discs and then through the filter media panels. As solids collect on the filter media, the flow of water is impeded and the water level rises inside the drum and triggers a backwash without stopping the filtration process. Water is discharged over weirs. As the backwash cycle begins, clean media is rotated into the flow path and the water level in the drum goes down. The backwash cycle continues to remove solids from the previously submerged media. While the discs are rotated, a small portion of treated water is pumped at high pressure to the nozzle assembly. The oscillating spray bar is a patented design developed by Hydrotech. This feature reduces the amount of water and power required for backwash. The high-pressure spray clears the solids from the filter media into a sludge collection trough that carries the sludge out of the disc filter. Once the dirty panels have been cleaned, the backwash cycle ends. The Hydrotech disc filter is an ideal solution for a variety of process applications. For example,
Okay, now I will show another video which is a good demonstration of the backwash process. This shows clearly the solids being captured on the inside of the discs, being washed off by the backwash spray, and the solids which then drop into the backwash trough and drain out by gravity from the unit. Okay, so that unit was actually at an intake water, in an intake water application, at a site here in Sweden. I would also like to show a few more videos. One of them which demonstrates how to remove a panel from the filter.
Yep.
Okay, now the reason that I show that video is because it's a normal question once you understand how the process works, how the unit works, to ask about some of the operations and maintenance activities and also the associated costs. Now, panel replacements are a reality of the system, but a unit that is well operated and maintained will typically not see a lot of panel replacements. So here is an example of an installation that we have in Sweden, which was commissioned in 2009 and has 18,000 filter panels. Of those 18,000 filter panels, in the first 10 years of operation, 50 pieces were replaced. Okay. Now I'm moving on to a comparison with sand filters. So the two different sand filters that we are looking at are gravity sand filters and pressure sand filters. And the study that I will be referencing is one that was made in Egypt while they were investigating the use of Hydrotech disc filters for municipal effluent polishing application. They ran a trial with the 3 units side by side at the same plant, and that's how they came up with results. Before I move on to the results, because I don't dwell on this point, I want to point out that one of the most interesting aspects is the size. So for a given flow, the difference between a Hydrotech filter and a pressurized sand filter, typically a Hydrotech filter will be 4 times smaller. The drawing that you're looking at is an installation drawing for an oil and gas site, but it is a valid principle. Regarding sand filters at this Egyptian site, some of the highlights from this report showed that the amount of wastewater from backwash for a gravity sand filter and a pressure media filter was 3%, and the Hydrotech disc filter was 1.75%. The number that we see for the Hydrotech disc filter is what we normally see, so between 1 and 3%. For the sand filter, it's actually on the low side. What we believe to see is been led to see is normally 5 to 10%. So you get decent savings in the amount of produced wastewater as a result of using a Hydrotech filter. This can be quite relevant when you're trying to improve your cycles of concentration at a cooling tower. Another important KPI is the amount of electricity that you will consume as a result of the filter. So a gravity sand filter is in the moderate range. A pressure media filter is a high power consumer with around 800 kilowatt hours per year at this site. And then a Hydrotech disc filter was 1/10 of that power consumption at 80,000 kilowatt hours per year. And then finally, the total cost of ownership for the Hydrotech was significantly less than the sand filter options. Something that isn't detailed in this report is the total installed cost as well, which is significantly even more higher for the sand filters due to the other civil works that are required for the extra basins that are required. For intake water, there are several design considerations that need to be taken before choosing a treatment technology. So the most critical ones are the water source and the water quality. So it could be ocean water, it could be river water, or it could be municipal reuse. And what is the acceptable filtrate water quality? So what is the purpose of the water that you'll be using? Now, we offer Hydrotech sometimes in a bundle together with an ActiFlow. An ActiFlow is a sand ballasted clarifier, which is a proprietary Veolia technology. And this is extremely good at taking varying TSS loads up to 10,000 milligrams per litre. And it's also very good at precipitating minerals that you don't want at your site. So in this process, coagulant and flocculant will be dosed at the ActiFlow and mixed together with a micro sand. The micro sand will enable the settling of most of the solids, and then it is returned through a hydrocyclone where the sand and the solids are separated and the sand is reused. The solids are then discharged. The filtrate out of the ActiFlow passes on to the Hydrotech filter for polishing. And what you can expect out of the Hydrotech filter, in the best case, is 5 milligrams per litre or 2 NTU. So a case that we've done recently in Pennsylvania is a power plant which has municipal wastewater coming via some core screens through an MBBR for ammonia reduction, passes through an ActiFlow for TSS reduction, and then passes through the Hydrotech Discfilter. And at this site, we've got a guarantee on the TSS at 7.5 milligrams per litre. The driver for this installation was water limitations. And this customer was looking at air-cooled condensers. Air-cooled coolers. But the cost for that was going to be approximately $10 million greater in capex than the cooling tower solution. Now, to enable the cooling tower solution, they had to find the water source which was available, and they found this municipal wastewater plant. Another alternative which you can go for in a scenario where the water supply does not have high peaks in TSS is the direct-to-disc option. In this case, influent water, feed water, can be up to 100 milligrams per litre. Here we will have tanks upstream of the filter for coagulation and flocculation, and then the solids and the water will pass through the filter and be separated out to a filtrate of to 5 milligrams per litre, 2 NTU. We have a good site in the UK where we are doing this. At the installation, they have peaks up to 110 milligrams per litre, but the average is actually very low in TSS. And the TSS limit that they've put on the installation is 10 milligrams per litre. This opens up a discussion for an interesting operating method. So you have the potential to operate without any coagulation and flocculation and just using the filter for protection of the downstream system. so taking the 5 milligrams per liter. Alternatively, you can keep your chemical dosing system running all the time, which is a safer solution to prevent any spikes passing through into your process system. This customer is choosing to operate the chemical dosing systems all the time. Now I'm going to talk about cooling tower sidestream filtration. Now, the two factors you need to consider when selecting or considering a sidestream filter are the airborne contaminants. In the States, there are significant areas with dust contamination, but other things to consider are pollen and basically any other airborne contaminants. And then also when there is poor intake water at the site, sidestream filtration can be used as a very good remedy to keep the water in the cooling tower clean. So the typical integration at a cooling tower is using a pressurized system. In that case, the filter will be integrated into the cooling tower system either by using a booster pump downstream of the recirculation pump. Otherwise, it could be taking part of the flow, typically about 5%, and bypassing the process, feeding it back to the cooling tower. For the integration of the Hydrotech solution, the recommended mode of integration is to have a separate pump at a similar point to the suction of the recirculation pump, and then passing it through the Hydrotech filter back into the cooling tower basin. Depending on the configuration of the cooling tower, this could be inside a concrete basin. Alternatively, it could be an installation where you retrofit a tank. In the image you're looking at here, we have tapped a pipe into the balancing pipe, which sits below the basins of these three cells. We draw the water up using a propeller pump, pass it through the disc filter, and then it drains by gravity back into the basin of the cooling tower. Here are some case studies for cooling tower sidestream filtration. First one is an industrial gas company where we have one disc filter. At this site, it's filtered with a 10 micron cloth. The TSS coming in is around 3 milligrams per liter, and the TSS coming out is also around 3 milligrams per liter. We do see that we get some solids in the backwash, and the customer says that they are very satisfied with the unit. It keeps the water extremely clean, and they have been able to skip a planned shutdown, which they had planned to do to clean out the basin. So they've been able to reduce the frequency of shutdowns at the cooling tower. Another project is a refinery in Azerbaijan with one filter for sidestream filtration. Here, the 10 micron cloth takes a TSS of 22 milligrams per liter down to 3.3 milligrams per liter. And this is mostly mostly dust and sand, which is contaminating the water. This site is yet to be built, so the results that we've got here are actually taken from a sample that we have received, and we have designed this system based on a mass balance of the average air contamination. So this is something that we can offer. We can offer to take a sample from your cooling tower and measure it, and then make a recommendation on what sort of system would best give you a clean filter, a clean cooling tower. The next reference is a sugar factory in Germany, and the driver for this project was because the customer has zero tolerance for legionella bacteria. So the customer was very interested in finding the best side stream filter to help with this concern of theirs, and so they did a pilot looking at Hydrotech filters, Amiad style filters, and pressurized sand filters. In the end, they chose the Hydrotech filter. The reason for that is because the Hydrotech filter has a short retention time of solids. Typically, you will see a backwash, one backwash for 30 seconds every minute or 2 minutes, compared with several days between backwashes, which is seen in a sand filter. So you don't get a buildup of solids in your system, meaning that the biology can propagate inside the sand filter, for example. The other feature that they liked was access to the filtration surface. So because the Hydrotech filter is 50% submerged in water and 50% of the filtration surface is accessible, this means that you can do a visual inspection and also clean it with a chemical if you believe that there's any biological growth. So here is our list of references for cooling towers. It's quite a lot in the States, and this can be made available to you. If you have any questions, please post your questions.
Thanks, William. As William just mentioned, we do have some time for questions, and we did have a few that have come in during the webinar, but just a reminder, as we are going through these questions, if you have any questions of your own, do feel free to put those in over on the right side. There is a questions box, so feel free to send those over, and we will try to answer as many questions that we have as time allows. So with that, William, I got one that came in, and I think it's referencing back to the industrial gases case study that you had mentioned. They're asking the TSS and turbidity feed is the same as the filtrate. Does that mean that the filter isn't functioning?
Right. Okay, I think that's a good question. Actually, this is what we typically see at a well-functioning site. What's happened here is that at the time of the sample grabbing, the cooling tower and the side stream filter had reached a steady state, meaning that there hadn't been a infiltration of dust or any contaminants in the short term. So the filter had reached a point where basically it was just maintaining a level of TSS in the water at around 3 milligrams per liter. But you could see from the size of the solids that were coming in at around 14 micron, and the size of the ones that were coming out at 1.5 micron, that it was actually removing most of the solids, any solids that were in the system.
Great, thank you. Another one that's come in as well. What are the O&M activities needed to keep the filter at capacity?
Okay. To keep the filter at capacity, it depends on the position of the installation. If it's in the intake, it's likely that you will need to perform chemical cleaning from time to time. What we see is that you can get a buildup of organic fouling or potentially scaling depending on the source of the water. So we have a chemical cleaning solution which can be sold as an accessory, and this is a trolley solution, which is our standard, which has an embedded sequence in the control system to do a chemical clean. Based on our experience, we can recommend certain chemicals to get to restore the capacity of the filter cloth. In terms of cooling tower side stream filtration, what we typically see is that the conditioning of the water in the cooling tower is typically good enough to maintain a good capacity in the filter cloth, in the filter.
Great, thanks. Another question, are there any signs that a cooling tower is experiencing dangerous levels of solids buildup?
Yes. There are some telltale signs which you can usually typically do a visual inspection to see. The most common one is going to be sagging fill. So what you need to do here is basically have an understanding of how the installation looked when it was built, if that's possible, and then compare the position of the fill inside the unit, where that is sitting compared to how it was originally. Another thing that can happen in the cooling tower, which can cause big issues, is when the spray nozzles at the top of the cooling tower go missing. That can also create a lot of erosion inside the fill, and those solids will probably end up somewhere in your cooling tower, in your recirculation system that you don't want them.
Great. Another one is, what are the typical recommended coagulants and polymers? And then are they any different than what is typically used for a clarifier? And then finally, last part of that question is there a risk of blinding the filter cloth?
Okay, so to answer the first question, it's really case by case. So this is something that we would need to evaluate depending on the water source. If you've got a specific scenario, you can send a mail and we can tell you about our experience there. Well, in a very similar case, but it does depend. Regarding fouling, yes, that can also be an issue. So if ferric is used, for example, upstream of the filter, then that can definitely blind the filter, and it needs to be remediated with the chemical cleaning.
Okay. Another question. I'm sorry.
No, I'll just elaborate there. I mean, typically the best remediation is to optimize the chemical dosing upstream of the filter. So what we normally do is what we normally see is that at startup there can be some issues and some plugging, but after resolving that and getting the chemical dosing upstream right, chemical fouling of the filters is less common.
Great. We've got time for a couple more questions here, and then we'll wrap it up. But another one that came in is, typically, how is the backwash treated or processed? Yeah, well, this is a site-by-site thing. So if it's intake water, there's a chance that you can actually send the backwash water directly back to the source. If you've got an existing wastewater plant, you might want to send it there. If you want to thicken it up, you might want to do that with a belt filter or any other thickening technology. So it's a case by case. Great. One final question here that we've got is, are there any disc filters following cold lime softening clarifiers? And then if yes, can you feed acid ahead of the filters?
We do have one installation. I'm not sure if there is acid fed upstream of the installation or not. So I think that to get more specifics on that answer, it's best to send us an email.
Great. I think that's all the questions that we've got today. So I do thank everybody for spending your time with us today. We have recorded the webinar, and you will be receiving a copy of that. And I thank William for his time as well. Thank you all.
Thank you very much.